Hello, everyone. Today, let's explore a super interesting and awesome mystery about the cosmos. Have you ever wondered why astronauts, when they get to space, look like they're flying? Just floating freely around the International Space Station, not stuck to the floor at all. A lot of people simply think it's because they've left Earth, entering an environment with zero gravity. But in reality, this is one of the biggest and most common misconceptions in all of science. The truth isn't that gravity disappears. It's that the way gravity is working creates that magical, weightless phenomenon. So what's the real reason? Today, we're pulling back the scientific curtain on this fascinating sight. Why gravity isn't gone. First, let's get one critical fact straight. Gravity does not disappear in space, no matter how far you go. Isaac Newton's law of universal gravitation states that any two objects with mass will attract each other. This pull gets weaker with distance, but it never drops to zero. Let's take the International Space Station, ISS, which orbits about 400 kilometers, about 250 miles, above the surface of Earth. After a quick calculation, we find that the force of Earth's gravity on the station and the astronauts inside is still about 90% as strong as it is on the ground. In other words, an astronaut who weighs 70 kilograms, 154 pounds on Earth, would still be pulled by Earth with a force equivalent to 63 kilograms, 139 pounds, on the station. So if gravity is still that powerful, why aren't they pinned to the floor of the ISS just like we are on Earth? The secret? Constant free fall. Imagine you're skydiving from a high-altitude plane. For that brief moment of free fall, you feel weightless, right? That's because you and the Earth are falling together under gravity, so there's no other force making you feel heavy. Now, let's scale that idea up to a cosmic level. The astronauts on the ISS aren't flying in the conventional sense. They're continuously falling around the Earth. The station is designed to travel in a circular orbit at a colossal speed, about 7.68 kilometers per second. That's over 17,000 miles per hour. This speed is the key. It ensures that for every second the station falls down towards the Earth due to gravity, the Earth's surface curves away from it by the exact same amount. The result? The station never actually hits the ground. It just keeps falling around the Earth forever. Newton's brilliant idea. To visualize this better, let's go back to a famous thought experiment from Newton. He wondered, if you fire a cannonball from a very tall mountain, how far will it go? If you fire it at a normal speed, it follows a curve and lands a few kilometers away. But if you increase the speed, its path gets flatter. If you could fire it at a perfect velocity, the orbital velocity, the cannonball would fall, but it would never hit the ground. Why? Because while the cannonball is falling down, the Earth is round, so its surface is also falling away from the cannonball's path at the same rate. The result? The cannonball ends up circling the Earth, becoming an artificial satellite. This is the principle for everything in orbit, from the moon to our weather satellites. The ISS is just a very large cannonball. It's constantly falling, but it's also moving sideways so fast that it perpetually misses the Earth. And the astronauts? They're inside the station, so they're falling with it. Since there's nothing pushing back up against them, like the floor does on Earth, they feel like they're floating. This is the phenomenon of weightlessness, or microgravity, even though gravity is still very much present. What would happen if the ISS suddenly stopped dead in its tracks? Gravity would take over instantly. It would pull the station and everything inside straight down, and in just about 30 minutes, it would slam into the atmosphere and burn up like a giant fireball. So, in short, astronauts floating in space isn't because Earth abandoned them or because gravity is gone. It's thanks to a perfect, beautiful balance between gravity and orbital motion. It's a scientific marvel where humans have learned to dance with the universe's great pull. The next time you see a video of an astronaut doing a happy somersault on the ISS, just remember, they're not escaping gravity. They're embracing it in the most scientific and elegant way possible. See you all in the next video. Remember to like and share to spread these fascinating scientific secrets.